A continuación escucharás mi conversación con Tanya Harrison. Tanya es doctora en geología por la Universidad de Western en Canadá. Actualmente se encuentra desarrollando un papel muy importante para la empresa Planet, como directora de estrategia científica. Planet se dedica a fotografiar con alta resolución y por completo el planeta Tierra haciendo uso de la red de satélites que orbitan el mismo. Esta labor, cuyo impacto se materializa en diferentes ámbitos como agricultura, ecología, clima, urbanismo, la combina con una actividad muy intensa a nivel de divulgación. Tanya forma parte de esos jóvenes líderes que impulsan un movimiento realmente inspirador, la búsqueda de lugares habitables fuera de la Tierra. En concreto, es una especialista en el conocimiento de las propiedades de Marte para tal fin. Esta conversación fue en inglés y se enmarcó en el acto de apertura de nuestro evento Mentes 20. En Mentes organizamos reuniones individuales de mentores y mentorizados. Durante 50 horas fuimos capaces de organizar más de 90 reuniones de una hora, muchas obviamente en paralelo, con un objetivo muy claro: crear una red internacional de talento actual, los mentores, y talento del futuro, los mentorizados. Este es el podcast de inteligencia artificial más humano. Si te gusta el contenido, suscríbete a nuestro canal de YouTube, iTunes o Spotify, o simplemente conecta con nuestra organización Clubes de Ciencia España a través de Twitter, Facebook o LinkedIn en @clubescienciaes. Y ahora aquí comienza mi conversación con Tanya. Okay, so let me start with one simple question. What do you do at your company, Planet, as the director of scientific strategy?
It's kind of broad. I guess for a little bit of background, Planet is a company that builds and operates satellites, mostly CubeSats. So they're these little tiny satellites that are about the size of a loaf of bread. And we have 150 of them orbiting the Earth right now, kind of all in a line, so that they build up coverage of the entire landmass of the Earth every single day. So we can watch for change on really short time scales. And this can be for things like looking at the effects of climate change. Um, we monitor human rights abuses in certain parts of the world. We can look at boats, like shipping traffic. We can look at airplanes. We look at how cities change over time. It's really amazing. And like, since my background is in geology, I'm interested in this a lot in the climate change aspect, especially in the Arctic, and how the Arctic is changing, because it's happening very quickly all over the Arctic. So before I came to Planet, I was actually a researcher at Arizona State University using planet imagery to look at landslides in the Canadian Arctic. And then eventually Planet started working with NASA. So they created an agreement to give NASA imagery, to give planet imagery to all NASA researchers. Mm-hmm. And so a lot of my role is working now with NASA researchers to help them learn how to use the data in their existing workflows. So they are used to specific data sets from satellites that NASA's been operating for decades. And now this is a whole new thing for them to learn how to use. But that also ties into deciding what we want to do as a company moving forward in terms of designing new satellites and making new image products, product like the actual image that we deliver to you, so that it's more useful for researchers down the line.
So when you mentioned that your images are the product, can you give me one example?
Yeah, so we make a lot of different types of images depending on what you need to do. I see. So like, some people, you might want an image that is basically, what does the Earth look like from the top of the atmosphere? And we call that top of atmosphere radiance. But some people want to know, what is the light that's actually reflecting off the surface of the Earth? Like, we don't want the atmosphere in the way. So that's called surface reflectance. And so we have algorithms that you can use to actually kind of remove the effects of the atmosphere from the images. And then we have things like mosaics, where we'll go through and find the least cloudy images, like the nicest quality images, and stitch those all together to make a map of just an area or a country or the entire world. We actually make a map of the whole world every month, which is really cool. You can actually like go on the website and see these huge mosaics of the earth that are changing month to month.
And let me ask you, are you using artificial intelligence to add the value to the images you collect with the satellites?
We only do a little bit of that internally. We're using it to do things like detect buildings, roads, boats, airplanes, and then in some places where there's oil, like in an area of the United States called the Permian Basin, we look for oil pads, well pads. But the research community at universities and NASA around the world have been using lots of different types of machine learning to process the imagery. So there are folks out of a group called NASA Harvest, which works on food security, for example. They go through, yeah. So they do things like crop type identification across mostly countries in Africa and then some parts of Eastern Europe. I think Ukraine is one area they're working in. So they try to go through and use machine learning to identify, what type of crop are they looking at, how much of it is there, how has that changed over time, and can they use that to create models to predict if there's going to be food insecurity in the future? Like, can we predict famines, for example?
I'm curious to know how good is the resolution of the images you take in terms of the things you can do and things that you can do with those images.
Uh, Not in terms of the resolution. So
Okay.
the images that we have that cover the planet every day, those are 3-meter resolution, which means that we can resolve things on the ground that are 9 meters in any direction. Um, and then we have another set of satellites, actually, that we have 21 separate satellites that are like the size of a dishwasher. So we've got the 150 small ones and then 21 dishwasher size ones. And those do images at 50 centimeters per pixel. So those we can resolve like individual cars, individual trees. So a lot of people actually use those two images in combination with each other. You can do some really large scale studies with the 3-meter data, but then if you want to go in and take a closer look, like if you don't just need to know if there's an airplane here or not, but you want to know what type of airplane it is, then you can use the 50 centimeter images.
Do you guys use a different spectrum range like infrared, ultraviolet instead of just visible light?
We go a little bit into the infrared just because the satellites are so small. We can't do much past that because you start to have to build really large coolers for your cameras to keep the images not too noisy. So we go out, I guess, for anybody that is doing stuff with wavelengths of light, our images are basically from red, green, or sorry, I guess from shortest to longest, we have blue, green, red, and near infrared. So we cut off before you hit 1000 nanometers in terms of wavelengths of light. Once you get past that, then you start having to make bigger satellites.
Tanya, do you think your role, like your responsibility as a scientific strategy, can be applied to other industries, not only in the space one?
I think you'd probably see the job title described at other companies beyond just space specifically as something like chief scientist. Somebody that has a science background and they can help drive the direction of the company as they're thinking about what they might want to do, specifically from a science background. Planet doesn't have a chief scientist, so I actually came in as a manager of science programs. And after I'd been here for about a year, I started to see how I wanted to shape my own career and what I thought I could contribute to the company. So I actually created my current job title by going to my boss and saying, I think I've demonstrated my value over the last year. I would like a promotion to, it's just the titles that we have internally. It's like, I would like a promotion from manager to director. And I think I don't just want to be pigeonholed as a scientist because it's too easy for the business side of things to maybe overlook that. And I think that the input that I have as a scientist is highly beneficial to decision making inside the company. And so I want to put strategy in my job title to help convey that more internally. And my boss said, yeah, that sounds great. So that's a piece of advice I would give the students actually. This has been a theme throughout my entire career, has just been, I've had a very clear vision at different points in time of what I wanted. And then I went out and made that happen. You have to be really proactive for this stuff. It's not always going to work out, but it's better. You have a higher chance than if you just sit back and do nothing.
Yes, definitely. Great piece of advice and great work, proactivity. So actually, I experienced a lack of vision during college. I don't consider myself at that time a proactive person. And I have the feeling that people like me studying science were the same. But what is your feeling there?
I think I'm a little abnormal in that I knew from the age of, well, I've been interested in space since I was 5, but I knew from the age of 11 specifically what I wanted to do. That's
Wow.
the year that the Pathfinder mission landed on Mars, one of NASA's a lander and a rover. And I saw that and I was like, I want to work on Mars rovers. And so I came in hyper focused and I knew like why I was there and what I wanted to do. I started just emailing professors before I was even old enough to be in college, asking them like, what should I be studying? Can I work with you? What university should I go to? Who should I be working with? So I don't think most like 11 to 14-year-olds are doing stuff like that. It's a little premature in a lot of cases, but I was so focused from early on. I was like, I'm going to figure out how to do this.
So at 11 years old, you were emailing professors to work with them?
Well, I guess I didn't have email when I was 11 because I'm old enough that like we didn't really have the internet at home. But I joined a local astronomy group called the Mars Society. And since I lived in Seattle at the time, we've got places there like Boeing and Microsoft and like all sorts of tech and aerospace stuff.
Yeah.
So the people, like the adults that were in that club started pointing me toward the right people. And like, I got to job shadow some folks at aerospace companies and went to the local university to listen to colloquium talks every now and then and their open houses and stuff to just start meeting people and figure out what I needed to do and who I should be talking to.
So you got interested in this field and you were immersed into an environment that fed you. Do you think that that was a key ingredient for your development?
I would say so. It was a great environment where I had all of these adults nurturing my enthusiasm and like seeing that they wanted me to be successful. And so I think if I had lived maybe in a small town or I wasn't close to such a vibrant aerospace community, it would have been really different. And I was very lucky that the University of Washington in Seattle has one of the world's best astronomy programs, which seems kind of funny because Seattle is famous for being cloudy and rainy all the time. So you wouldn't expect it to be a hub of astronomy. You can't see the stars very often. But having that in my backyard was, I think, also really helpful.
So you were interested in space exploration, but why did you study geology in particular? So what was the rationale for that?
So that's a great question. I knew I wanted to study Mars. And so when I went into university, I thought, well, planets are in space. I should be an astronomer, right? But I didn't actually learn until near the end of my 3rd year of 4 years that I should have actually been a geologist if you want to study the surface of another planet. Astronomy is really great if you want to study stars or galaxies or the formation of planets, but to study the planets themselves, provided you're studying a rocky planet like Mars or Venus or Mercury, not something like Jupiter, for example. You really want to be a geologist. And so in graduate school, I switched to studying geology, which was a huge change. I was basically starting over. I had to take a bunch of like undergraduate intro courses all over again, not because I hadn't taken intro to geology as an undergraduate. So now in grad school, I had to take all those foundational courses on top of the ones for the graduate degree. And then for some reason still only got 1 degree out of it, which is kind of funny. But it turned out that was a much better fit. I really liked being able to study rocks on the surface of another planet rather than when I was studying astronomy, I was doing something called spectroscopy, which is literally looking at squiggly lines that are light coming from a star, and those lines tell you what the star is made out of, which is cool. I did some cool stuff, but to me, Mars was way more interesting.
Okay, so let's start talking about Mars, the planet. So have you worked for SpaceX, and what is your opinion about their intention, the steps they are making towards traveling to Mars?
I've never gotten to meet Elon personally, but I did work with SpaceX on, they had a series of, I guess we would call them landing site workshops. So actually trying to help figure out where they would land humans in the future when they're going to send them to Mars. And their plan is to send humans to Mars as early as 2024, which in space terms is right around the corner. That's only 4 years away.
Yeah.
That's quite an ambitious timeline. I don't think that they will actually hit that, but I like the fact that they make it something tangible. Like that's a time that we can imagine in our heads. It's not, we're going to Mars 10, 20, 30 years from now. We're going to Mars in like 5 to 10 years.
Yes,
We can all probably imagine that.
Let's put a deadline and then let's see if we can make it.
Yeah, and I think you're more motivated to accomplish it or to try to accomplish it if it's a deadline that is something that you can picture in your head. If it's something you're working toward 20 years from now, you can just keep putting it off and get distracted by other things. So I really hope that they do it. I think it will completely change how people perceive space exploration if one of the first missions to Mars is not NASA or the European Space Agency or China, but it's a private company of a guy that had a vision to build a spaceship and send it to Mars. That's really cool.
So the other reason why I wanted to talk with you was that, the topic about business, making business in space. So as far as I know, telecommunication is the most relevant business activity right now, but I think there are others. So what others?
Telecommunications is definitely the biggest industry in space,
Yeah.
but we have other things too, like Planet, for example. You have a lot of Earth observing satellite companies. Some of those, like Planet, takes pictures of the Earth, but there are other satellites that do radar, so radio imaging of the planet, which is really great for looking for things like ships that are sailing across the ocean but trying to hide. They can't hide from radar. Radar can peer through clouds too, which is really nice. Generally, if you're taking an optical image from space, like in the wavelengths that we can see in, sometimes clouds get in the way. That's kind of annoying. There's also companies that work on the space station. So there's a company that works to get payloads from Earth into space, experiments or things to launch other people's satellites. We actually used them to launch our first satellites from the space station. And now the big one, I guess the two big company areas that are expanding right now, one is basically space junk cleanup. So trying to figure out how we can capture dead satellites and deorbit them, so burn them up in the atmosphere so they don't run out of fuel and then just spiral into other things in orbit and smash up satellites that are working, which is an actual problem. This is come up more than once.
It is very unlikely to happen because we have a picture of the space as something like, reduced, but it can happen. And if it happens, it could be very painful.
Yeah, the thing is, like, space is really big, but the useful orbits around Earth are very small in the grand scheme of things. So everything that's in orbit around Earth tends to hang out in certain ranges. So you'll have stuff between, like, say 300 and 500 kilometers. And then you have stuff out where you've got GPS satellites that are at 36,000 kilometers. Out there, it's not very crowded. But when you're in what we call low Earth orbit, that sort of 300 to 500 kilometer range, there's a a lot of stuff there, especially now that the cost to launch things is getting cheaper and cheaper. And so the danger goes up with the more stuff you have there. If you have a satellite that fails, or something like doesn't go quite right and it doesn't go into the correct orbit, we could potentially have things that crash into each other. And then when they crash, all the debris from that can start flying off into space and impact other satellites. And we've seen some places where we've seen micrometeorites actually smash through solar panels of satellites, for example, and that can cause a lot of problems. So we want to make sure that that doesn't happen from unnatural things that we're putting into space. So there's a few companies based out of places like Japan and the US trying to figure out how to clean up that debris before it becomes a problem. And then the other big area is what we call in-space manufacturing. So launching things like all the pieces to build the space station, that took years and it was very expensive. And launching huge satellites, they're big, they're heavy, it costs millions, well, tens to hundreds of millions of dollars to launch them. But if you can launch smaller pieces and then assemble those in space, it can be a lot cheaper. So there's some companies that are trying to figure out how to actually construct satellites in orbit using robots. And that's going to be really interesting to see like how that evolves over time.
So this is my last question before we jump into the students' questions. So here it is. Have your vision, your life goal when you were a child already been achieved?
My goal had been to work on Mars rovers, and I got to do that. And now I work for an Earth observing company, so I'm not working on Mars, at least as my day job. I still do Mars stuff outside of working for Planet. Like I just worked on a mission concept with NASA for the last year or so. But I got to do all the things that I wanted to do, and then was kind of like, oh, what's the next thing that I could do? And
That's my question.
yeah, so I'm excited to be where I am now. I do miss Mars. Like, it's definitely cooler if someone asks what you do for work. If you're like, I work on the Mars rover, people are like, what? That's so cool. Tell me more. If you tell them that you work for an Earth observing satellite company, they're like, oh, what's that? Like, what are you taking pictures of? It's not quite as exciting, or it takes more explanation for people to realize that it's exciting, unless it's somebody that's already into space. So I guess my goal is to get people to be more excited about why we take pictures of Earth from space and how it impacts our lives every day, and how we can use that to make the world a better place.
I mean, I'm excited, super excited.
Yay.
So let me go through some of the questions, okay?
Okay,
So
I see there were a lot, so that's great.
yeah, definitely. So Sarah is asking, what is the reach of Planet, the company you're working for, and do you study other planets besides Earth?
So right now we only work on Earth, but if you, I should have been wearing a planet shirt or something. If you look at the logo, it says planet and there's like a circle around the letter P and then a period at the end of planet. And one of the founders of the company said that's meant to represent the Earth and the moon. And he's like, well, we called it planet for a reason. It's not called Earth. So maybe someday in the future we will image other planets. I certainly want us to send satellites to Mars. So maybe in like 10 years I can convince the company to do that.
Yeah, these things takes time.
Yeah.
Okay, so also Carolina, she's asking. Let me read it in Spanish. Okay, so the first question was, what was the, if you recall, what was the moment in your life that means more for your, to be successful in reaching those goals that you had when you were a child? So do you have anything in mind, like, okay, this opportunity, this person it changed my mind, or opened the door for me to get into this?
That's a good question. I think In terms of like the moment that maybe changed the whole direction of my life, it was during my master's degree. My original plan had been to get a master's degree in geology and then immediately continue on for a PhD.
Hmm.
But I didn't have the best experience in graduate school. And so I wasn't sure that I wanted to stay in school after that. And so I had started emailing a bunch of professors trying to see if anybody might be hiring for like a data processing kind of job. Because I had worked before at my other university processing data from the Hubble Space Telescope and some other ground based telescopes for professors who just needed somebody to do that for them. And I really liked that. I thought like getting my hands into the data was fun. And one of those people that I emailed suggested that I look at this company in San Diego that builds and operates cameras for Mars missions.
Hmm.
And I never would have thought to look for a job there because I just would have guessed that all they needed were engineers to build cameras. And it turned out that they had a very small team of scientists. And right around the time I was graduating, they were hiring for a scientist. And I immediately applied. I bugged them incessantly to remind them how interested I was in the job, and eventually they hired me. Um, and so I don't think I've ever, the person that I got that email from, I've only met them maybe once or twice in person. We don't know each other well. She probably wouldn't even remember me like if we met in real life again.
Hmm.
But that moment changed my entire life by just telling me go look at this company,
I see.
because I never would have done that on my own.
And do you feel like a little bit worried when you are, pushing because you are so excited that you want to do something, but people are busy, they have all the interest, but then you are pushing, pushing, pushing. So do you feel worried about that? And do you think that it's a good sign of a proactive person?
I think proactivity makes you stand out from the crowd because a lot of people won't go to that effort because they're either nervous or they don't think they need to. But there is a lot of competition out there. And so you have to figure out how to make yourself stand out. And that genuine enthusiasm for what you want to do, whether it's space or anything else, can really resonate with people. Um, and I'm sure there's a fine line between being enthusiastic and being annoying. So,
Yeah.
don't email the people like every day being like, hey, I really want this job. I maybe emailed them like once every 2 weeks or something because it was just because their hiring process was very slow. That might not necessarily be the case other places. But yeah, reaching out to universities or companies or people that work at these places that you're interested in, just start like making them know your name and know what your background is and what you're interested in and like how excited you might be to work there, because that networking can really come into it'll be beneficial down the line.
Yeah, exactly. That's what we were talking at the very beginning of this opening was about creating that network. Actually, the mission of our foundation is to create a network of talent that is almost out of the academic world, and talent that is 10 years or 15 years afar from that academic world, and they have been successful. So we put them together and we create that connection between nodes, which are the people.
That's awesome.
Yeah. It's so simple, but about networks that when they interact, the nodes interact, there are emergent properties from there. So, and the emergent properties can be translated in opportunities. So
Absolutely.
let's create networks. Okay, so Jan is asking, I'm curious the relationship of Planet with other countries. So, of course, Planet is a US company. If you want to make a study in a country that is not where you are working in, do you have to ask them for permission to take those images and study them? That's a great question. And if not, do you think this will change in the future?
So we actually don't have to get permission from any of the countries to take pictures. We have to get permission from the US government because we're based in the US. And we actually also have an office in Berlin. So we have to get certain permissions from the European Union. Um, so we have a few offices around, but most of them are in the US, and then there's this one in Berlin. There's actually one in Canada too, so we're expanding all over the place. But no, we can take pictures anywhere on the ground. We don't really do any like preference for one place over the other, or not take pictures in one place because it might make someone else upset. Our whole goal is to basically democratize space. Like, we're taking pictures of the whole world every day, for people to use as, I guess, not entirely as they wish. We actually have an internal ethics board to make sure that we don't have, bad people trying to use the data to do bad things. Because, there are people that might want to use the images for horrible reasons, but we try to make sure that they can't get access to those. But we do take pictures everywhere.
Okay. So actually, I mean, that question makes sense, because when we are talking, for example, about drones, which everybody can use and put a camera. So there is a new legal framework that came out because of the drone activity. We have also regulation for the airlines and stuff, but the legal work only only in the atmosphere. If you go outside, I guess
Yeah, it's much easier once you're in space.
Okay. So the next one is Monica. So far we have 3 girls asking and 1 guy. That's great. I like it. I would like to ask, if it is appropriate, what did you study at college or even after college? Which choices in education and courses have led you to the job you do nowadays? Well, you mentioned that you study geology, but maybe you can specify some of the classes that you take or something like that make the difference.
Yeah. So in my undergraduate, I actually majored in astronomy and physics. My university really encouraged that you double major in something with astronomy, so that you would have a better chance of getting a job after you graduated, because there are only so many jobs out there in astronomy. But I'm sure with the physics degree, there are a lot of job opportunities out there in physics. So they just want to make sure that you would be able to get a job. But since I knew I liked Mars, I don't even remember how I ended up in this class, but I was wanting to do something with geology. And so I took a class called Intro to Glaciology, or the study of ice and glaciers and snow.
Wow.
And I fell in love. I thought that glaciers were actually really cool. And so it made me want to do something with ice on Mars. And then in my master's degree, technically my master's degree is in earth and environmental sciences, but I studied Mars, so the name is a little bit deceiving. But the classes that I had to take were things like mineralogy, identifying rocks. I took a class on soils, where we literally just went out into the field and dug holes, and then looked at the layers of soil in the holes to figure out what had happened over time in an area, which might sound really boring, but once you start going out to the field in geology, it's actually a very powerful feeling. You learn how to just kind of look at the area around you and very quickly put together the geologic history of what's happened. And I remember maybe a year or so into my master's degree going to Joshua Tree National Park, which is in Southern California, and getting out of the van with my friend and looking around. And I was like, I think this used to be a lake. And we found a sign at the park that said, lo and behold, we were standing in the middle of an old lake bed. So it's really cool to be able to learn this stuff and then apply it in your day-to-day life, and just look around and say, oh, I think there was a glacier here, or, oh, we're standing next to a volcano, which sometimes is not always obvious. So I really love that. And then my PhD is in planetary science with geology with a specialization in planetary science. So I didn't have to take a lot of courses for that, because the way the school worked in Canada, I basically did all my classes in one semester. But I did things like I went up in Northern Ontario to study an impact crater in person, which was really cool. We did a field school where we drove around the desert southwest of the United States to go to a bunch of what we call analog sites. So places on Earth that are kind of like things we see on other planets, so you can study them in person. There's actually a really famous Mars analog site in Spain, in Rio Tinto. There's like an acid mine drainage area where you've got all sorts of weird minerals that are like things we see on Mars. I've never been there, but I want to go.
Me neither. Okay, so if you come to Spain, we will go together. I will go with you.
Field trip.
Yeah. Actually, it's in the. I'm from the south of Spain, so actually I always say that I have a southern accent in Spanish and also in English because I was living in Atlanta.
Oh.
And yeah, it's not close to my hometown, but well, I have a desert in my hometown.
Oh,
So
cool.
so yeah, I mean, let me go to the next question, which is, there is a word that also excites me, and I want to have a follow-up question afterwards. So the next one is Adela saying, what can we learn from Mars, especially from geology point of view, to apply here in the Earth, like for example in agriculture?
Ooh, from Mars to Earth. One of the nice things about Mars is that you don't have any trees or water or humans in the way. So you actually get to just look at the rocks. And that's really helpful for some things like impact craters specifically. We don't have a lot of impact craters that are left on the Earth because they've either eroded away from wind and water and volcanic eruptions and plate tectonics just erasing them, or stuff fell into the oceans and it's very hard for us to find because it's under all that water. But we want to study impact processes because, you know, impacts have had horrible effects on the Earth in the past, like killing off all the dinosaurs. But they might have also created little environments for life to thrive, like these little, we call hydrothermal vents. There's some at the bottom of the ocean, and there's some ideas that life might have started there. And impact craters, when the stuff hits the planet, it actually generates a lot of heat. And if you have heat plus water, that tends to be really good for life. So there have been a lot of studies kind of looking at both Earth and Mars in terms of craters to figure out, could craters here have created abodes for life? And if they did, could there have been life on Mars in these little tiny hydrothermal environments inside craters? I guess for agriculture specifically, we haven't done much that's like applied to Mars to bring back to Earth. But there are things that we would have to think about for Mars that could be beneficial on Earth. Mars doesn't have a lot of water, so we need to be able to have advances in things like aeroponics and hydroponics, where you're not using a lot of water or there's not a lot of nutrients in the soil. So we have to figure out how to make hardier crops with less resources. And how can you create higher yield crops so you can feed people there and make sure that they're healthy and not just living on dehydrated food like we do a lot of the time on the space station, because that'll get boring pretty fast if you're living on Mars the whole rest of your life just eating out of little dehydrated food packets. So I think the sustainable agriculture part will be a huge thing that can help us here on Earth, especially as we become more resource scarce and we're dealing with things like places that are turning into deserts because of climate change, which, you know, hopefully we can combat climate change so it doesn't become a problem, but we should be prepared just in case.
Yeah. So definitely, I think agriculture is key when we are talking about colonizing or moving to another planet. Some people, and actually, the reason is clear. So our civilization started with the first version of agriculture and hunting in the Earth. Of course, in Mars, we don't know if we have other type of living things that we can hunt and eat. Maybe bacteria, I don't know. But for sure, if we can learn how to crop, that will be essential. And it's a challenge, right?
Yeah, definitely. We can only grow a few things on the space station right now with the limited amount of stuff you can grow through things like aeroponics and hydroponics. and it's not enough to sustain people. Like on the space station is not independently sustainable. We send up crew like resupply missions all the time with fresh fruits and vegetables and meat and water and all this stuff. So we actually don't know how to live sustainably off Earth at the moment because we're not doing it in space right now. But if we go to the moon, that's close enough to Earth that we can still send some resupplies if we need to. But Mars, it takes you 8 months to get there, and you can only get there really once every 2 years, and then 8 months to get back. So you can't be reliant on resupply missions to sustain a base on Mars.
Yeah, and do you think with the work that you guys are doing in Planet, um, with imagineering and the things that you can learn from outside the Earth about the surface and all the agricultural activity that there is there, do you think that you can have any insight on how uh, food grow or the crops grow and stuff depending on the weather and the conditions, to extrapolate that to Mars? Because in Mars we are going to be also looking at Mars from the surface in the next years.
Yeah. It would be tricky to take something like that and extrapolate it to Mars, because a lot of what we're seeing in terms of agriculture on Earth is so tied to like farming practices and the climate in any specific area and the types of crops that they either can or have decided to grow in an area. Um, so it might be a little hard to take that and apply it directly to Mars. But we could learn stuff from like smaller scale things, like maybe genetic engineering of crops, for example. That could be something we could apply to Mars.
Okay. Uh, let me also jump into another question. So Crystal uh, asked, which finding during your job as planetary scientist have you impressed or have you impressed most with that finding?
Um, I think in terms of like something personally that I did, um, I part of my job was looking at landslides on Mars, and specifically landslides that formed very recently that looked like they could have formed with water. And I found like 8 or 9 new landslides very early in my career that had formed within just the last few years. So we had pictures where you had like no landslide, and then weeks to years later, we had another picture where there was a landslide. And so trying to take that and figure out from that how these landslides were forming, which might sound kind of boring, but for Mars, it's really significant because these landslides, the shapes of them suggest that there must have been liquid water involved in their formation on Mars today. And anywhere on Earth that we have liquid water, there's something that has managed to survive in that water. So this is a huge deal for Mars. And then I spent my whole PhD actually mapping out every single one of these landslides on Mars. There's tens of thousands of them. And then NASA ended up making all of those sites what we call planetary protection sites, because there could potentially be something alive in them. So if you want to go there, you have to have a mission that is super sterilized to make sure that we're not going to contaminate any potential Mars life with Earth life. So now there's this whole map of all these dots that I made that NASA put into a report, and they're like, yeah, you can't land in any of these places. It's like, oh, sorry, everybody.
Okay. So I feel very, very funny and at the same time interesting to, those type of questions that we give we give for granted here in the Earth. Okay, so here you cannot go inside because there is a protection ecosystem, or here you cannot go inside because this is a property of whatever. So now thinking about, okay, we have another planet and we are putting the same ideas on top of that with good reasons, okay? But I think it's super funny.
Yeah, I guess I never thought about it in those terms, but this is a very good experiment right now of planetary protection.
Okay, that makes me think that, well, there is a hope in terms of, the bad things that the human civilization has. When we move to another planet, we are gonna move with a different, mind, set of mind, like thinking in a more collaborative way. But I think at the end of the day, we're gonna have the same issues there, right?
Yeah, unfortunately, I think like the first people that go there, you'll have just a few. They're all very like altruistic scientists and engineers and things like that. But then as you start building an entire society and that society grows, you're going to get more people with different backgrounds, different viewpoints. Um, but maybe like starting with a good foundation from the very beginning and then having that foundation kind of culturally instilled in everybody that either comes to Mars or is born on Mars, maybe it gives us a chance to do things better. Like we'll have to learn how to be really nice to each other. Like you're stuck inside a sealed dome essentially where you can't talk to anybody on Earth in real time because the light time delay is too short, or sorry, too long. So you can only talk to people on Mars. You all have to get along really well. You can't have capitalism on Mars because there's not enough resources to just make random things, you know. So it really will be a society where like everybody has to chip in and do their part. Everybody has to help take care of everybody else because the stakes are so high. Like if you don't, everybody dies.
Yeah,
So we'll see how that goes. I'm certainly curious. And we can look at things like Antarctica as a good example. You have these science bases where you do have some other people that aren't just scientists. You've got cooks, you've got maintenance people, you've got hairdressers. They've even got a hairdresser down there. And they've managed to create this whole like small sustainable city, almost a city of a few hundred people alone at the South Pole.
uh-huh.
So it's kind of like Mars.
Yeah. Actually, I think I have to talk with for the podcast with somebody that I know that have been living there and could share some of the experience. Have you been in the Antarctica?
I haven't. It's on my list of like things that I would love to do someday.
Okay, and what about the space? Have you been in the space?
No, again, I would love to someday. Maybe once they start doing space tourism flights.
Yeah, that's another mm, business space that someday.
Yeah,
Uh,
hopefully soon.
okay, so it's we have 8 minutes to 5 o'clock, and at 5 o'clock in Spain, of course, we are going to start our mentoring session. I think I read 5 or 6 questions from the students, and I would like to wrap up. Okay, of course, I feel that I would like to be talking with you for hours. Actually, it is not because of your knowledge and the topic that I'm very interested, but also because you look like a very close like a person that you can connect with, and you are very open to talk and humble. So I mean, thank you very much for being that kind of person, inspiring other people to be like that, but also achieve a lot of things, right?
Oh, thank you.
No, thank you.